Learning goals. Welcome to this learning session on chemical formulae, elements, compounds, ions. In this course, we shall address introduction to elements, compounds, and formulae, atoms, molecules, and chemical notation, understanding ions, types and examples, balancing charges in ionic compounds, writing chemical formulae, practice. There will be a quiz at the end to test your knowledge.
Introduction to chemical formulae. Chemical formulae are a concise way to represent chemical substances, providing essential information about their composition. They indicate the types of atoms present and their relative numbers within a molecule or compound. Understanding these formulae is fundamental to all areas of chemistry, from basic reactions to complex molecular structures. For instance, the formula H2O instantly tells us that water is composed of 2 hydrogen atoms and 1 oxygen atom, a fact crucial for understanding its properties and reactions. This simple notation allows chemists worldwide to communicate complex information efficiently. Understanding elements. An element is a pure substance consisting of only one type of atom, defined by the unique number of protons in its nucleus. Each element is assigned a specific chemical symbol, which is a shorthand notation. These symbols typically consist of 1, 2, or occasionally 3 letters, always starting with a capital letter, followed by lowercase letters. For example, the symbol for gold is Au, derived from its Latin name aurum, while iron is Fe from ferrum. The periodic table systematically organizes all known elements, making it an indispensable tool for chemists, providing a wealth of information about each element's properties. Atoms, the building blocks. An atom is the smallest indivisible particle of an element that still retains the chemical properties of that element. It consists of a central nucleus containing protons and neutrons, surrounded by electrons orbiting in shells. Atoms are the fundamental units that combine to form all matter. While atoms are incredibly small, typically around 0.1 to 0.5 nanometers in diameter, their internal structure and electron configurations dictate how they interact with other atoms, forming the basis of all chemical reactions. The arrangement of electrons determines an atom's reactivity. Molecules, joined atoms. A molecule is formed when 2 or more atoms are chemically bonded together, acting as a single unit. These atoms can be of the same element or different elements. Many elements that exist as gases at room temperature, such as hydrogen, H2, and oxygen, O2, naturally occur as diatomic molecules, meaning they consist of 2 atoms of the same element joined together. Nitrogen gas, which makes up about 78% of Earth's atmosphere, also exists as diatomic molecules, N2, where 2 nitrogen atoms are held together by a very strong triple bond. This strong bond makes nitrogen gas relatively unreactive, which is important for maintaining a stable atmosphere. A compound is a substance formed when 2 or more different elements are chemically bonded together in a fixed ratio. Unlike mixtures, compounds have unique properties distinct from their constituent elements. Their chemical formula explicitly state the types and quantities of atoms involved. For example, sodium, a reactive metal, and chlorine, a poisonous gas, combine to form sodium chloride table salt, a stable compound with entirely different properties. The formula NaCl indicates 1 sodium atom and 1 chlorine atom, demonstrating a fundamental chemical transformation. Chemical symbols and notation. Chemical formula use element symbols and subscripts to represent the composition of compounds. The symbol for an element indicates its presence, and a subscript number following the symbol denotes the number of atoms of that element in the smallest unit of the compound. If no subscript is present, it implies there is only 1 atom of that element. For instance, in glucose, 6H12O6, the subscripts clearly show 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms, providing a complete atomic count for the molecule. This precise notation is essential for calculating molecular weights and understanding chemical reactions. Introducing ions, charged particles. An ion is an atom or a group of atoms that has gained or lost one or more electrons, resulting in an overall electrical charge. Atoms are naturally neutral, with an equal number of protons and electrons. When this balance is disturbed, an ion is formed. The process of forming ions is crucial for many chemical reactions, including the formation of ionic bonds, which are fundamental to the structure of many minerals and biological molecules. This charge imbalance drives many chemical interactions. Cations and anions. Ions are categorized into 2 main types: cations and anions. Cations are positively charged ions, typically formed when metal atoms lose electrons. Anions are negatively charged ions, usually formed when non-metal atoms gain electrons. This electron transfer allows atoms to achieve a more stable electron configuration, often resembling that of a noble gas. For example, a sodium atom, Na, readily loses 1 electron to become a sodium ion, Na+, achieving the stable electron configuration of neon. Conversely, a chlorine atom, Cl, gains 1 electron to become a chloride ion, Cl-, achieving the stable configuration of argon. These stable configurations are energetically favorable. Polyatomic ions, sulfate example. Some ions are not single atoms, but rather groups of atoms covalently bonded together that carry an overall electrical charge. These are known as polyatomic ions. A common example is the sulfate ion, represented as SO42 mass. This formula indicates 1 sulfur atom and 4 oxygen atoms, collectively carrying a 2 negative charge. Another important polyatomic ion is the ammonium ion, NH4+, which consists of 1 nitrogen atom and 4 hydrogen atoms, carrying a 1+ positive charge. Polyatomic ions often behave as a single unit in chemical reactions, maintaining their internal structure while interacting with other ions. Balancing charges in ionic compounds. When ionic compounds form, the total positive charge from the cations must exactly balance the total negative charge from the anions, resulting in a neutral compound. This principle dictates the ratio in which ions combine. For instance, in sodium sulfate, Na2SO4, 2 sodium ions, Na+, are needed to balance the 2 charge of 1 sulfate ion, SO4. This charge balancing is why calcium chloride has the formula CaCl2 or Cl. 1 Ca2+ ion requires 2 Cl ions to achieve electrical neutrality. Understanding this concept is crucial for correctly predicting the formula of ionic compounds. Writing chemical formula. Practice writing chemical formulae requires understanding the valencies or charges of the constituent elements and ions. For elements that exist as diatomic molecules, the formula is straightforward, such as Br2 for bromine. For simple ionic compounds, the charges must be balanced to achieve neutrality, often using the criss-cross method. Bromine is one of only 2 elements that are liquid at room temperature, the other being mercury. Its diatomic nature, Br2, is common among halogens, which include F2, Cl2, and I2, all existing as 2-atom molecules in their elemental form. Complex compounds, magnesium hydroxide. When a compound contains polyatomic ions, and more than one of that polyatomic ion is needed to balance the charge, the polyatomic ion is enclosed in parentheses, and the subscript is placed outside the parentheses. For example, the formula for magnesium hydroxide is MgOH2. This indicates 1 magnesium atom and 2 hydroxide ions. Magnesium hydroxide, commonly known as milk of magnesia, is used as an antacid and a laxative. The parentheses are crucial here. Writing MgOH2 would incorrectly imply 1 magnesium, 1 oxygen, and 2 hydrogen atoms, rather than 2 distinct hydroxide groups, fundamentally altering the compound's identity.
Summary. Well done, you have completed the course, Chemical Formulae. Elements, compounds, ions. You should now be familiar with Introduction to Elements, Compounds, and Formulae. Atoms, molecules, and chemical notation. Understanding ions, types and examples. Balancing charges in ionic compounds. Writing chemical formulae. Practice. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.